Implicit differentiation, let's get started. The first function x squared times y to the 8th minus xy equals to 70. I'm not going to waste any time to isolate x on y on one side. So implicit differentiation, I am going to differentiate both sides with respect to x. So I'm going to write d dx, and then this is the left side, x squared y to the 8th minus xy, and then the other side, d dx, and then 70. So the other side is easy. The derivative of 70 is equals to 0. So when you differentiate each terms on the left side, do you see that there is a x squared y to the 8? So this is a product of two variables, right? So there is a product rule in there, and then the x times y, there is another product rule in there. All right, and then the next step is you have d dx, and then this is a x squared y to the 8th, and then minus d dx, the derivative of x times y, and then the other side is equals to 0. So we have one product rule on each square bracket. Oh, by the way, what is product rule? Still remember? Product rule. So product rule. So product rule is fg prime plus gf prime, right? So fg prime, so f is x squared, so we have x squared, the derivative of y to the 8, so remember this, we treat y as x, so we treat, I should do this in another color. So we treat y as an x, so we treat y as x, and then take the derivative, and then write dy dx at the end. Remember that? So now, f is x squared, and then g prime, the derivative of y to the 8, so you bring the 8 down, and then y to the 7. So since this is a y and we are doing this with respect to x, we have to write down dy dx. Are you following? So let's repeat this again. We have x squared y to the 8, right? So product rule is fg prime, so we copy x squared over, and then we take the derivative of y to the 8. So you bring the 8 down, and then 8 minus 1 is 7. So since this is a y and we are doing this with respect to x, you have to leave a dy dx at the end. And then plus gf prime, so g is y to the 8th, and then f prime is x squared, so x squared is with respect to x, so you just have to write 2x. There is no need to write dy dx at the end because this is with respect to x. So this is a product rule. And then minus, so since we have to minus another product rule, I am going to use a square bracket to box that product rule. And then the whole result is equals to 0. So on the other side, so we have another product rule. So the fg prime, the copy x over, the derivative of y is equals to 1. And then since this is a y, we have to mark a dy dx. And then plus g, which is y, the derivative of x is equals to 1. So since we are doing this with respect to x, there is no need to write dy dx. Okay, now, let's write down this as well. So this is another product rule. And then the next step is we have to fully expand all the terms. So the first term is ax squared y to the 7, and then a dy dx plus 2x y to the 8th, and then minus x dy dx, and then minus y equals to 0. So now you see how important the square bracket is because you have to distribute the minus. And then the next step is you have to leave all the dy dx on one side. So you have to leave all the dy dx on one side. So this term stays on the left, this stays on the left. And then what about the rest? The rest goes to the other side. So the other side has a 0. So we have a y, right? So we have a y and then minus 2x y to the 8th. And then on the left hand side, we have to factor out the dy dx. So factor out the dy dx. And then after you do that, you have ax squared y to the 7 and then minus x. So all you have to do is you divide the square bracket on both sides. So you have a dy dx that is equals to y minus 2x y to the 8th divided by ax squared y to the 7 minus x. So this is your final answer. So we just differentiate the given equation using implicit differentiation. All right, so let's try the other one, the blue one. So first of all, we will differentiate both sides with respect to x. So we have x to the 1/2 plus y to the 3/2. And then we differentiate the other side. The other side is just 0, right? The derivative of 4 is equals to 0. Okay, on the left-hand side, so first of all, the derivative of x to the 1/2. So since this is with respect to x, or if you want, I can write one more line for you. So we are doing this with respect to x, and then we are differentiate this with respect to x. So the other side is just equals to 0 because the derivative of 4 is equals to 0. 4 is a constant value. So with respect to x, everything looks fine. So bring the 1/2 down, and then 1/2 minus 1 is negative 1/2. Do you need a dy dx at the end? The answer is no, because this is with respect to x, and in this differentiation, x is my independent variable. But when it comes to the next term, you have a y as the independent variable, you do need a dy dx. And then plus you bring the 3/2 down, and then y, that minus 1 is past the 1/2, and then this time you need a dy dx. Read the red for me. Treat y as an x, take the derivative, so which we just did, we bring the power down, take the power minus 1, and then since this is a y, you are doing this with respect to x, you have to leave a dy dx at the end. So this is what you have to do every time you do implicit differentiation. So every time you do this, repeat the red things, which is right over here, to yourself. All right, and then next step, we have to keep the dy dx on one side. So we have 3/2 y to the 1/2, and then we have a dy dx, and then we toss the 1/2 to the other side, which is subtracting that term on both sides, and then we divide both sides by the fraction and the y. So we have a dy dx, so that is equals to negative 1/2 x to the negative 1/2 divided by 3/2, and then y to the 1/2. I am sure that you can take this as your final answer if you are doing a written exam in my class. But I am sure if you are doing this if you are doing this online, they would like you to clean this up. So the dy dx, let's clean this up. So you have a fraction divided by another fraction, right? So you have a negative 1/2 divided by another fraction, which is you are taking the reciprocal of the fraction in the denominator. And then you have x to the 1/2, so it looks like that is 1 divided by, so that brings the 1/2 to downstairs, and then y to the 1/2, that you keep that downstairs. And then the last step is you get rid of the 2, so you have a dy dx that is equals to negative, so you have a 3 in the denominator, and then this is a 1. So since they are both in square root, it is okay to write it like that. So you can take this as your final answer. So regarding this, if you have square root of 2 times square root of 2, that is square root of 2 times 2, which is square root of 4, that is equals to 2. You can write it like that. So if you have a square root of 3 times square root of 3, that is equals to square root of 3 times 3, so that is the square root of 9, which is equals to 3. If you have a square root of 4 times square root of 4, that is the square root of 4 times 4, which is the square root of 16, that is equals to 4, right? But if you just start right here, 2 times 2, that equals to 4. All right, so if you're doing homework online, I am pretty sure they would like to answer to be in this way. But if you're doing written exam, especially in my class, I accept this. I accept complex fraction. All right, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, click the subscribe button if you are new to the channel. I will see you all in the next one. Signing out.